Hello everyone, I'm Dr. Shruti Dikshit, Associate Professor, Sage School of Engineering and Technology, Sage University, Bhopal. Today we are going to discuss about the topic multiplexing, which is from this course Data Communication, Unit number 2. First of all, we will understand the meaning of multiplexing. Multiplexing, many to one, and demultiplexing. What is happening in case of transmitter and in case of receiver. Multiplexing, it is a set of techniques that allows the simultaneous transmission of multiple signals across a single data link. Means many to one. Multiplexing is done using a device called multiplexer. In short, MUX, that combines n input lines. For example, if n is equals to 4, then it will combine 4 input lines to generate one output. In short, many to one. And at the receiving end, a device called demultiplexer, in short, DMUX, is used that separates signals into its component signals, one input and several outputs. Means 4 outputs are there, means one input and 4 outputs, 1 to 4 or 1 to many. This is the simple diagram of multiplexing. Here at the transmitter side, n input lines are there. If n is equals to 4, then 4 lines will be converted, means 4 customers' data will be transmitted through the one link, and the 4 n is equals to 4, then 4 subscribers' data will pass through the transmission medium. And at the receiver end, demultiplexing will happen. Demultiplexing means one to many, means if 4 subscribers' data are coming from the single transmission media, then it will be bifurcated into the 4 output lines because our value of n is equals to 4. Here, two important advantages of multiplexing. More than one signals can be sent over a single medium or link. And here, the effective use of the bandwidth of medium. This diagram shows the multiplexing versus no multiplexing. In case of no multiplexing, here we have to connect each and every device to each other, but unable to send data to multiple devices. But using multiplexing, we can send multiple signals data from through the single transmission media, and we can receive the multiple channels data through a single transmission media, and it will be transmitted to the multiple channels through the single path. So this is the basic difference between multiplexing and non-multiplexing. Here there are few types of multiplexing. It is subcategorized on the basis of two types of signals, analog signals as well as digital signal. On the basis of analog signal, it is having two categories, frequency division multiplexing and wavelength division multiplexing. And on the basis of digital signal, it is categorized into time division multiplexing. Again, time division multiplexing is subdivided into two types, synchronous time division multiplexing and asynchronous time division multiplexing technique. In this lecture, we will discuss about the analog type of multiplexing signal, means and frequency division multiplexing, in short FDM. Frequency division multiplex, it is an analog technique. Signals of different frequencies are combined into a composite signal and is transmitted on the single link. Bandwidth of link should be greater than the combined bandwidth of the various channels. Each signal is having different frequency. And here the concept of guard band is used in order to prevent the overlapping. The guard band means channels are separated by the strips of unused bandwidth called as guard bands. Here the diagram of frequency division multiplexing. 3 in case of n. The value of n is 3. Here, 3 telephone subscribers data is transmitted to the single path, one path, 3 channels, channel 1, channel 2, and channel 3. The same way, having the channel 1 having the different frequency, channel 2 having the different frequency, and channel 3 having the different frequency. There will be guard band in between this frequency in order to avoid the overlapping of the signal. The one of the important application of frequency division multiplexing is telephone network as well as cellular telephone network. Here the telephone subscriber residential telephones will be connected to an end office through a single line, means many subscribers, and it will be converted in with the data of the multiple telephone subscribers will be transmitted to the single transmission media or path. Here it will be forwarded to the from end office to tandem office and based on the switching to the regional offices. Here is the another example of frequency division multiplexing is cellular telephone network. Again, the same frequency division concept is used in case of cellular network. Here are the few applications of frequency division multiplexing. It is used for frequency modulation as well as amplitude modulation radio broadcasting, as we have discussed in the previous lectures. It is also used in television broadcasting as well as it is used first generation cellular telephones also uses frequency division multiplexing. So these are the few applications of frequency division multiplexing. Here multiplexing in frequency domain. Here, if we want to send the 3 subscribers data, so 3 subscribers data, the first subscribers data, F1, second F2, and 3, third one will be F3, and the 3 subscribers data will be combined, and there will be a gap in between this F1 and F2 as well as F2 and F3 known as guard bands, and it will be sent through the, as it is shown in the diagram, it will be the bandwidth of the link should be greater than the bandwidth of the transmitted signal. Here the demultiplexing in frequency domain, again the all the separated frequencies F1, F2 and F3 will be combined and it will be filtered to separate out for at the receiver end. The combined frequency will be filtered out through these filters F1, F2 and F3 and it will be passed through the demodulator. So this is the one of the important type of multiplexing technique, frequency division multiplexing. In the next lecture, we will discuss about the wavelength division multiplexing as well as time division multiplexing. Thank you so much.